Welcome back, and in this episode we're going to talk about variables and types in C#. This is going to be just a gentle introduction, so it's not going to be a comprehensive overview of all the possible types in C#, but we will get through all of them as we go along and see different problems. So let's get started. Before moving on, I'm going to create a new project since this is the Hello World project, and it's gonna remain like this, very simple. So let's create a new project in here, and we're going to call it, I'm going to move to the folder up above, and now let's create .NET new console, and we're going to call it variables. Okay. And now I'm going to open that folder. Should be in here. There it is. And now we have the variables program, which will just display Hello World again. I'm going to open the terminal. Okay, and we are inside this folder right here. Let's try to run the program like we did before, and it says here in order to build and debug we're missing some files, so let's add them. They just created some folders in here, and now if we do .NET run, we will see Hello World like before, and we see it. Okay, now what we see here is this text. This text is called a string because it's just a series of characters. We have the character H and E and L and O and so on. Sorry. We see the string that is between quotes. So all string literals like this, we call this a string literal because we have the actual value of the string and we define it within string quotes. We will see in the future how we can manipulate strings and how we can insert data into strings and how can we add strings together or split them and so on. So this is not the purpose of this tutorial. Instead, we are just going to move on and see what the other types of data that we can use in C#. So if we don't want to use a string like this, another type of data could be a single character. So maybe we would want to display just a single character, like H from Hello World. We can also display this to the console the same way we displayed a string. So let's see how that would work. If I run .NET run again, we should just see an H displayed. And of course I need to save the file first, and now run .NET run again. And we just see the H. This would be useful, for example, if we want to read an input from the console, like there's a question, do you want to create this file? And the options can be yes or no. Then you might want to input a single character for Y for yes and N for no. So there are different uses. Also, if you want to split the string into characters and then pass through each character one at a time to check for certain characteristics of the letters, maybe to see if it's uppercase or not, and so on. So there is a use for just using a single character from a string. Of course, there's nothing stopping us from defining a string made of a single character like this. And this would also display H on the console. So if I run this again, we still see H. Okay. The same way we use a single character, we can also use single numbers. Single numbers, it can be useful, for example, in a ticketing system where you want to let the user input how many tickets they want to buy. for 1 person, 2 person, 3 person. So if you have a value like that, that is an integer value, it can only have whole values like 1, 2, 3, and not 1.5 and 2.7 and so on. And those are called integers. So we would write them like this. If we can also pass them as input to the write line, and if we run this, we would just see 1 displayed to the console. So you can see write line can take any number of variables, of types of variables, sorry. It can take strings, we saw, it can take characters, and it can take integers. If I hover over this, you can also see the type, and there it's system int32. Int32 because it uses 32 bits to represent this number. And the same as in the case of strings and characters, this value of 1 is called a literal because it can only have this value. So when we pass 1 to write line would only be able to display the value 1 because this is what we passed to it in this case. Of course, we don't want to use only whole numbers. Well, in the case of money, for example, we can have fractional units. So things can cost $1.30 or 50 euros and 25 cents. So if we would want to display fractional numbers, we just put a dot. And this automatically becomes a different data type. And you see here, this is a system double. We won't go into the details of how these types are represented in memory because this goes far beyond the scope of the current episode. We might get to such details when we try to solve specific computer science problems. But for the moment, doubles have this property that they can represent fractional units as well. And like for strings, characters, integers, and all the other types, this is also a literal. So the value, when we write a value like this in code, this is a literal. And let's save this so we can see that it works as well. And we see 10.6. Of course, we can do operations with numbers and operations with strings and with characters. So let's see if we go back to strings and we would say A plus B. This way we can concatenate the two string literals, and write line will display a single string that will be the concatenation of these two strings. So if I save this, as we expect, we should see at the console AB. If we want a space between A and B, then we need to define the space as well. So I added a space here, and now if I save this, we have A space B. As with strings, we can do the same with numbers. So I would say here 1 plus 2, and the answer should be 3. And we have a 3 here. Same goes for doubles. And we should get a 3.4. So let's see. And we have 3.4. Now, if we would try to do the same thing with characters, we would get a surprise. So if we would try to do something like A plus B, this doesn't make too much sense because you can't get a single character out of two characters like this. But what C# will try to do in this case is it will convert these characters into their numerical representation and then add the two corresponding numbers for each letter together. And if I run this, you will see that I get the result 195. That is because A has a specific numeric value and B has also a specific numeric value. And these values you can view. I open Google and let's say ASCII code table. And continue with recommended settings. So let's see, the code for lowercase a in decimal is 97 and for B is 98. So 97 plus 98 should be 195. So if I would run here, 97 plus 98, run, it is 195. So adding the two characters A plus B is the same thing as adding the numbers 97 and 98. If you're wondering why is that table called ASCII table, this is because ASCII stands for American Standard Code for Information Interchange. Inside the computer, everything is just bits, zeros and ones. And zeros and ones, by definition, are numbers in binary. And numbers in binary have an equivalent for numbers in decimal, so you can convert between decimal to binary and vice versa. Here you can also see the representation in hexadecimal or in octodecimal and so on. So that is why inside the computer the number A has a representation in bits. Those bits correspond to the numeric value 97. If we talked about bits, there is also another data type called byte. And the byte is used to represent 8 bits of data. This is useful, for example, when we have file content that can represent a video file or music file or any type of file that isn't just plain text. In that case, we can read that file byte by byte into C# and process it however we see fit. We will go through file reading and writing, what C# calls streams, and so on. But that will be again in future episodes. So coming back to variables, up until now we only used literals. So we used the values of these this data. But it's not useful to write only programs like this. So you can only do so much if you just use hard-coded values. You create a program and you use it once to find the result, but then if you want to find the result for a different set of data, then you would have to write the data again. In order to avoid that, what we can do is, instead of using literals like this, using what is called hard-coded data like this, we can use variables. And by their very name, a variable means that it can change with different values. So it is variable, it's not static. It's even though static has a different meaning in C#, it's not something that doesn't change. A variable is something that changes. So let us see how we define a variable. If we would say just A equals 5, this would not be enough because C# expects you to also tell it the type of variable. So not just the name, but also the type. In this case of 5, we expect it to be an integer, so we will just say A equals 5. And now A is a variable that has in it the value 5. The difference is, after this statement, at any point during our program, we can come and say, okay, I want A to become something different, like 10. I changed my mind, now I want A to be 10. And we can write line like this. So, as you can see, the console write line A doesn't change, but the value of A changes between these two executions. And if we run this code, we should see first a 5 and then a 10. And we can see first a 5 and then a 10. This is extremely useful because using variables like this means that we can have a single set of input data that is passed by the user or read from files and so on. And the code that we write can operate on any values of that data. So if we process a movie file, it doesn't matter what's inside the content of the movie file, we can process it in the same way. If we want to compute interest rate, let's say, we just provide the input data once, like the sum and the interest, and then we can see the final sum after a number of years. And we don't have to hard code the data. We can just use different values for years, different values for the input sum, and then we'll see what is the end result without having to write every time the values. Let me just illustrate that. So let's say that we have the initial sum equals 100 initial, and we have an interest rate equals 5, and this is, let's call it 5%, and if it's 5%, that means it's 0.05. Now 0.05 is not an integer, but it is a double. It has a fractional part. And now the final sum that we have at the end would be sum, the new sum becomes the old sum plus sum times interest rate. But now we have a problem because initially sum was an integer, but if you multiply an integer with a double, you're not going to necessarily always get an integer. You might get a fractional part as well. So in this case, we have to declare also the sum as a double. And now we calculated the interest rate. Console write line sum. So basically at the end, if we have 100 plus 100 times 5%, we should get 105. So let's see if this is correct. And we do have 105. Now, the nice thing about this is, because we're using variables, this piece of code will stay the same, but we can easily change here, and instead of 100 we can say 200. Now when we run it, we will see the new value. So using variables, the data can change, but the algorithm, the set of operations and instructions remain the same. Okay, the next thing, up until now, we only used single values like one double, one integer, one character, or a string. What happens if we have a series of such values. Like we have a sensor that detects the temperature in the room, and we want to see how the temperature varies over time. Now, this, by definition, is a series of data. If we want to record this series of data, it would be pretty difficult to use something like int t0 equals 1. Then you would record t1 equals 2. And you would record t2 equals 3, and so on. So it would be very tedious to work with programs like this. What happens if you have 100 values? You would have to declare 100 variables. So to avoid that, C# allows you to declare a data type that is a series of pieces of information. Like in the case of integers, you would declare what is called an array of integers. And then you would only use a value like t, and C# also wants to know how many such integers you want to allocate. So in this case, you would declare them like, I don't know, let's say we want to record the last 10 or once per hour, the last 24 hours of temperatures. If now, once we declared it, this variable doesn't have anything in it, so if we want to actually put useful values, like actually record the temperatures, we would need to say something like t, and we have to tell it for which hour we want. So for hour 0, we would put, I don't know, 23 degrees. The next hour, we would mark 22. And so on and so forth. 23, we would have 20 degrees. As you can see, the indexing, this is called indexing, starts at 0. So the first value in the array of 24 values is at position 0. The last value, because we started from 0, is 23, one less. So the first is 1 less than 1, so it's 0. The last is 1 less than 24, which is 23. I will leave this video at this point, and in the next video we will see how we can operate with such arrays, because again it would be pretty tedious to write 100 values like this. So what kind of structure can we use in our programs to manipulate such arrays so that we don't have to manipulate them one by one? And we will see this in the next video, together with other interesting topics. See you next time!